Hello friends, welcome back to Shiksha Junction. So today we have brought you with the SCADA presentation. So in the last lectures, lot many students have asked for the SCADA presentations. So because of that, we have actually introduced now the new episode on SCADA. So you might be knowing about the SCADA basically, just like lot many people know, but some controlling systems in automation. So this is one of the finest product what we have in automation. So SCADA is a software part, total software. So it can be implemented in the laptops or desktops, but it requires a Windows-based operating platform in which it can be installed. So this is not possible in some Android phone. So it has to be implemented in Windows. So SCADA basically stands for Supervisory Control and Data Acquisition System. So what it means basically, why it has been defined as SCADA, or why we call it as a SCADA, why not some other name? Okay. So first we have to understand, see in a plant basically, so the plant is segregated into different sectors and different divisions are there. Just like for an example, if you are taking about the thermal power plant, so many sections are there, and it has been spread out in acres of the land. Okay, just like a wagon tippler area or a coal storage area or coal handling plant. Then AHP is there, ash handling plant. Then we have a DM plant for the water. Then we have a turbine section. We have a boiler section. So all these sections are being spread out. So when I'm talking about the large, just like in petrochemical industries or oil and gas systems, so these systems are like spread out in kilometers somewhere. Okay, specifically if you are talking about the oil and gas system. So being it's a plant, it's a process. So for an engineer or for any operator who wants to monitor all these field instruments, all these parameters, what is the pressure, what is the flow, so continuously he wants to monitor all these parameters in a particular one point at one system. So this is possible only when you have a SCADA system. So that means if you remotely want to control or monitor the entire process, you have only one solution, call it as a SCADA system. So that is why, or this is why this is basically used, or you can say that it's a happening automation product as compared to any other product. Just like if you are talking about the PLCs or HMI systems or drive systems. So these has to be connected. These other systems has to be connected there itself live to the field instruments. You can't remove it. You can't carry with you. Whereas SCADA is a software. So if I connect it in some desktop, or if I install this software into some desktop and I'm sitting in a remote place somewhere 10 kilometers away from the plant, and with the IP address I can connect. IP address means I am talking about the internet facility. So some media has to be there. If you are connected with some internet facility, you can remotely access all this information. That is a good thing about SCADA. Now, coming to the specified things. So this is how, this is what it stands for: supervisory control and data acquisition. That means supervisory means it can monitor. Control means controlling the process. So it can monitor as well as control and data acquisition. So what do you mean by data acquisition? Conversion, accessing the information, conversion of the information. So that is what data acquisition is. So it converts the electrical signals which are getting from the PLCs and other systems, and it will convert to the user defined numbers. Okay, just like if I am interested in putting the degree temperature as a 30 degrees Celsius, so it will show 30 degree, 45 degree. Whereas in the field, it is in the electrical form, maybe in millivolts, maybe in 4 to 20 milliamperes, in some other electrical forms which we can't understand. So it has to be defined as what we understand as a user friend. So that has to be converted. So that is the job of SCADA. So you can see on the screen, just like SCADA refers to a system that collects data from various sensors at the factory. So SCADA can't be connected directly to your sensors. First of all, this has to be very much clear in your mind. See how you will be connect a proximity sensor to your computer. It's really not possible. So SCADA depends on hardware. So which hardware? PLC is the hardware. HMI is the hardware. DCS is the hardware. PID controllers are there. So these are all hardwares which are actually connected to the field, From there, you will access the information through some data cable. Okay, just like communication cables, just like your USB cables are there. So we are not using USB cable. This is just for an example. So we are using actually protocols or networking cables. One of the best example is Ethernet. Ethernet is the same cable which you use to connect your computers. So the same cable can be used for accessing the data from the hardware, just like PLC and DCS systems. And these all information through this cable will be connected to your computers. And from computer, it will be accessed to the SCADA. So this is how it's a long chain. Okay. So basically, you are accessing all the information, getting all the information from some third party hardware to your SCADA systems. So SCADA will show you on the desktop in the animated form. So collection of the second para, the collection of equipment that will provide an operator at a remote location with enough information to determine the status of a particular piece of equipment or entire substations and cause actions to take place regarding the equipment or network. Of course, see, if you have the information on your screen, you can do whatever you want. Just like if I want to know what is the pressure for the last 10 hours. So what was the temperature of my boiler for the last 2 days? So I can analyze it. So whenever I'm talking about analyzing the information, analyzing the things, you require a lot many information that you can get it from the SCADA. That is really not possible from the PLC or DCS system because these systems only show you the live data. They don't have enough memory to store it. So don't assume that other automation products have a terabytes or gigabytes of some hard disks in them and they will be storing that. It is really not possible. But SCADA has because it is using your computers. So furthermore, adding some more important things in this, just like SCADA system refer to a system consisting of a number of remote terminal units. Here RTU is nothing but PLC, collecting field data connected back to the master station via communication system. This is what I was telling about, information accessing it from the PLC. The master station displays the acquired data and also allows the operator to perform remote control tasks. The accurate and timely data, that is a real-time data, allows for optimization of the operations of the plant and process. So if any fault occurred, if any trip has been occurred, so with the same time and with the same movement, it will generate the alarms. So even though I'm not there in the front of the machine, but I will know what is the status of my machine, because of which fault it has been stopped. If it has been tripped because of over voltage or over current or any short circuit condition. So everything I can know it from a remote. So I will not be always in front of my process. I will not be in front of my conveyor system, but still I know what is happening in my plant. The further benefit is more efficient, reliable, and most importantly, safer operations. This all results in a lower cost of operations compared to the earlier non-automated systems. See, still in India and of course, in some countries, we still have the machines which are semi-automatic. So if you want to make it automated plant, so you require some automation products. So one of them is the SCADA systems. So just like in oil and gas and thermal power plant, these are the area where lot many things are dangerous for a human being. Okay. High steam, high pressure, high temperatures. So it's really not possible for a human being to go as a routine issues are there. So that has to be solved there, or he has to stand there. So for such a heat is there, such a high pressure is there. So it's really not possible to stand a human being to there. So it's a dangerous area, hazardous area. So when you have a hazardous area, dangerous area, which is not suitable for any of the human being, and from a remote place, if you want to operate a wall, if you want to start a motor, if you want to stop the motor, if any fire hazard has occurred, from a far away, I want to start my fire alarm systems. Smoke detectors are there. So if all these things has to be operated remotely, then you have only one solution called as SCADA. So what are the objectives of a SCADA system in a plant? Monitoring, of course, it's a continuous monitoring of the parameters, just like voltage, current. Then measurement, of course, measurement of variables for process, because without measuring, how you will be defining things. Data acquisition. So frequent acquisition of data from PLCs and data loggers. Data loggers is nothing but the storage areas. So before computers, there were data loggers. There were hardware device which is to store the data whatever is happening every day. So that has to be stored in somewhere. So they used to use data loggers. Now we don't require these data loggers. SCADA itself can be act like a data loggers. Then data communication, transmission and receiving of large amounts of data from the field to control center. Every day, every moment, every milliseconds. So if you are working in the thermal power plant, you might be having thousands of field instruments. Okay, lot many flow transmitters, lot many pressure transmitters, lot many temperature transmitters. They are accessing every time, every millisecond they are sending the data. So where you will be putting all this? So the amount of data, okay, so all these things has to be logged somewhere, some in Excel sheets, some in SQL servers, or you might be having some third party softwares through which you want to access the data, you want to store the data. So for all this purpose you require this SCADA system which will do for it. Then controlling online real-time control for closed loop and open loop process. Of course, if I want to set some set point for my process, okay, I have to set some point for my pressure, that the pressure should not be increased to such amount. So I have a set point for that. So when you have such things and you want to control the systems, so SCADA can also help you for this. Then automation, of course, for all this purpose, why we are requiring, main objective of the SCADA is automation. So automatic tasks of switching of transmission lines, circuit breakers. So from a safe distance, if you want to operate, just like in a substation or switchyard, so you require a safe distance. You will not be going regularly into the substations or switchyard to operate the operator because high voltages are there. So you can't rely on this thing. It's really not possible. So for a safe manner, if you want to operate the process or the systems, so this is will be the SCADA will be helpful for you. What are the functions of the SCADA system? So these are the actual functions, or you can also call it as the features of the SCADA systems. So on the picture on the right hand side, you can see the desktop showing me the graphical things. So it all shows in the graphical things. This is how it will look once you install the SCADA system. So in the SCADA systems, you don't have to create anything. All these tanks, pipelines, valves, different types of valves, different types of pumps, motor, conveyors, all these objects are as an image is already there in the library. You have to simply grab it from the library, put it on the screen. Based on your client requirement, what is his requirement, how you want it, how you want to represent his particular plant. So based on his requirement, you have to create the pages. So these pages are called as process screens. So these are called as a process. In front of you, you can see the process screen is already there. Okay. So this is all developed by the beginners, just like a SCADA programmer. There are some special jobs available in the field called as a SCADA program. So this is what he will be doing. So don't assume that it will be requiring a high skilled person or something like this. Nothing like this. Just knowledge of a basic SCADA, how to create the graphics, how to put it on the screen, and how to create the tags, how to attach the tags, and how it can be connected to PLC. Different types of PLCs are there. So how it has to be connected. So these are all simple and you can say that it's just a general purpose features available which can be easily learned out and you can create it. So we don't require a 10 years of experience or 20 years of experience for creating all this stuff. So function of the SCADA, I can see data acquisition, conversions and all this thing, information display, supervisory control, alarm and train processing. Just like alarms are just like you can say warnings. Okay, in plant some fire has happened, so alarm will generate. Pressure has increased beyond some certain limit, alarm will generate. So this for alarms in the field, you might be seeing, if you have visited in the industrial visits during the your industrial visits, you might be seeing some lightning systems are there, some buzzers are there, okay, some sound alarm, something like this. So these are for alarming. So we have some physical elements which will sound it, or they will show some lighting, some tear lights are there, buzzers are there, so that will show you flashing light, something like this. But they are showing us that now the fault has occurred. So once the fault occurs, then they will show you the sound and all these things. But before happening, okay, I can predict it through alarming condition. In the SCADA, they will just log it, just like whatever the values which you have put it from the pressure. Just like once it reaches beyond this limit, alarming condition has to be shown on the screen. So it will show some alarming text on the screen itself that this value is going beyond the limits. So take some action regarding this. So that all comes in the alarm. So alarms will be stored as in a tabular sheet, just like on which date, what was the time, and all this stuff. Trained is nothing but the CR, just like what you have used in the CR in your labs. Exactly in a digital pattern, it will be shown. It will put some graphical views, just like in a X and Y axis, it will plot some graphs, just like in a sine wave, some triangular waves. So as the process is increasing, decreasing, continuously it will generate the sheets, it will generate the graphs. Then the fifth point is information storage and reports. Of course, whatever it has been created for the last 2 days, for the last 2 months, for the entire year, all this information has to be stored same. I want some reports for that one. So that reports can also be generated with a simple printout. Data calculations, some manipulations are there, some VCPs are there, which has to be calculated properly. Some conversions are there, just like from degree Celsius to degree Fahrenheit, from centimeter to some kilometers, or some just like mm to cm. So some all these functions are there, multiplications and some formulas may be there. So that has to be extracted, that has to manipulate it. So this all comes under data calculations. Then processing with the PLCs, control and connectivity, just like if you want to connect some PLCs. So every PLC is different. One is made by Allen Bradley, another is by Siemens. SCADA is made by some other third party. So SCADA manufacturers, lot many manufacturers are there who are manufacturing this, who are creating this software called SCADA. Just like Allen Bradley, he has his own SCADA. Siemens, they have their own SCADA. So every particular PLC manufacturers are also creating this SCADA software. So SCADA can be connected to any PLC. It is not a particular domain, or it doesn't some proprietary that it will be connected only Allen Bradley with the Allen Bradley software or product. It's not like that. Any SCADA can be connected to any PLC, but how it has to be connected? What are the different techniques? What are the different driver softwares? What are the different options where I have to click it? So this all comes under the basically connectivity features. So that is again a big chapter. And where the SCADA is used, I have already told you in thermal power plant, oil and gas. So each and every sector now, manufacturing sector, they are using SCADA systems because everybody wants to control and monitor the values from a center place. They don't want to create a complex structure. Just one screen and that's it. I want the entire plant should be shown on my screen itself. So it's a very easy job, even for a maintenance people, even for a production line. So all in a one go. Even now you can connect this to your mobile phones. In the mobile phones you can access the things. Some few parameters you can access in mobile phone also. It has come to that level now. So you can see electrical power generations, water and sewages like water treatment plants, manufacturing systems, robotics, automation, monitoring process, transit, just like electricity, subways, trams, trolley buses, even for metro stations and railways, they are using the SCADA system. Indian entire railway stations and railway network is all connected through SCADA system. All the metros in India, they are actually monitored every day, every millisecond. They are monitoring on SCADA system. Traffic signals, even in Indian roads, whatever the different traffic signals are there, that can be also be monitored. Okay, to such level they have reached actually. So SCADA is a product which can be implemented in lot many areas. So as a SCADA engineer, as a SCADA programmer, new types of jobs have been created now. This I have not seen in last 10 years basically. So suddenly this has been increased now. So before that, it was called as an automation engineer required with this knowledge and that knowledge. But now they have started with a new post called SCADA engineer and SCADA programmer. This has been recently started, and lot many engineers are required in this field as well. So SCADA programming or SCADA generally connects like this. You can see here, SCADA can be connected to multiple PLCs. It can be connected to HMI system also. So HMI is basically, you can say, for a particular one machine or one piece of equipment, whereas SCADA is for the entire process, entire plant. Again, PLC is connected to individual equipment, just like one conveyor systems or two conveyor systems, it will be connected to PLCs. Okay. So PLC can be connected to multiple equipments, but for remote operation, PLC is not suitable. For that, you have to use SCADA. So SCADA can be connected to multiple elements through PLCs. And this is how it looks with your screen on your computer, iPad, or some mobile phones. So now even on the Play Store, if you just type their Allen Bradley SCADA, if you type their Siemens SCADA, you will find lot many apps related to that. Of course, it is you have to pay some money for that one, because if you want to access the server, so definitely server charges has to be paid. If you get a subscription of 1 year or 2 years or 6 months, so you can access it through your plant process and all this stuff. So I will show you the screen. So this is the real SCADA applications in the plant. So this is food and beverage system, just like a bottling plant, you can assume it. Pepsi is there, Coca-Cola is there. So lot many bottling and food beverage systems. So this is how they monitor the entire system, and this is how they are actually controlling their process. You can see here, see. So the live data, they can see here, which process is running. This is related to Schneider Electric, one of the company, which is in automation. So the production line officers, the maintenance people, all can monitor. You can see the entire process, how many bottles coming down on the line, which conveyor is running, which has been faulted. If any sensor has sensed it, that some bottle has been not properly, so that can be also be counted. How many parts have been rejected. So whatever the products have been created on daily basis, so that has to be reported to the production officer. So every time an engineer will not be standing there reporting it down. So some system has to be there. So whatever the daily failures, daily maintenance and daily tripping conditions, faults, and whatever the production is going on, all are detected properly through the PLC, and from PLC it gets into the SCADA, and from SCADA it goes to a third-party software where it will be locked, stored, just like some SQL Server, Oracle systems, something like this. So this is how it is managed nowadays, the entire plant. And this is the area where as an engineer you will be working. So you have to ask the question to yourself itself, are you ready for these systems? Because this is what Industrial 4.0 is called as. Fully automated system, where even the IT system is being connected nowadays with automation. So each and every, you can see the displays of system as well, which has been showing you the status. So batches, packaging, cleaning, controlling the systems, controlling the conveyors, motors and pumps, duty, calculating the duty hours. So the entire system is fully automated and monitored from the SCADA. So this is what is basically. Okay. So if you have any questions, any queries, anytime you can connect to Shiksha Junction. We will love to have your queries. And if you are interested for such element, just like for courses or training purpose, definitely you can connect to us. We have many experts, industrial experts, who can have a chat with you, who can have a case studies, can share the case studies with you. They can share their experience, what they have done. Based on that, we can have a proper program related to you. So thank you very much for today. Thanks a lot.